Today we are in section 3.6. We're going to learn how to multiply matrices by hand. I will show you how to use your calculator tomorrow in class, but we will have to know how to multiply these by hand as well. First thing we need to know is that in order to multiply matrices, the columns of the first must equal the number of rows of the second matrix. Okay, so what does that mean? If you have two matrices, A and a B matrix, you need to know the size of each one. So let's just say the size of the A matrix is m by n. M rows, n columns. And the size of the B matrix is n by p. What you have to do is look at the number of columns in the first matrix. That's this one. It always goes row column. The number of columns in the first matrix has to be equal to the number of rows from the second matrix. So if those two numbers are the same, then yes, you have a definable matrix multiplication, and the answer matrix size will be the leftover values, the rows from here and the columns from the B matrix. So it would be, size would be m by p when you're done. So if the number of columns in the first matrix is equal to the number of rows of the second matrix, you do have a definable matrix multiplication. First couple questions, can you actually multiply these? In other words, are these defined? If your A matrix is 4 by 3 and your B matrix is 3 by 2, number of columns in the first has to equal the number of rows in the second. Yes, that's the same number, so yes, this is a definable matrix. The answer would be a 4 by 2 matrix. Second question, your A matrix is 3 by 4, your B matrix is 3 by 2. These two numbers, not the same. This is not a definable matrix multiplication. Now, how do you actually multiply them? When you multiply by hand, we go across the rows in the first matrix and we go down the columns of the second matrix. So the phrase that I want you to think to yourself is always this: slide over, slide down. I color-coded this so you can see how the multiplication is going to work. When you multiply, we're going to start in the top row, and then we're going to multiply that by the first column. So follow the green. We're going to go across this row, and we're going to multiply it by the numbers coming down the first column. We'll take the first entries in each matrix. Take A times E, written right here, A times E. Now, slide over and slide down. Multiply the B number times the G number. We need to add those together. That sum will give us the first entry of the matrix. Then we have to go over to the second position. Second position is highlighted in blue. So we're still in the first row, but now we're going to multiply by the second column, which has the F and the H numbers. So first position is A times F, plus slide over, slide down, B times H. Add those two together, there's your second position. The third entry will go right here. We have to move down now, we're in the second row, but we're back to the first column, so follow the yellow. Not yellow brick road, just follow yellow. C times D, or excuse me, the CD values and the EG values. So starting with C, C times E, now slide over, slide down, D times G, add those together and you'll get this position right here. And then the last position will be from the last row and the last column. First numbers up are C times F, then slide over, slide down, D times H, add those together and you'll come up with your last value. Very confusing when you look at it at first. But once we do a few of these, you'll get the hang of it. Just remember, slide over, slide down, and we always want to start on the top row with the first column, top row, second column, then second row, first column, second row, second column. All right, let's try it. We're going to do A times B. Your A matrix is 2, negative 3, 1, 5. B matrix is 1, negative 4, 3, negative 2. All right, so remember, we're going to slide over, slide down. 2 times 1 is 2, plus negative 3 times 3 is negative 9. That's my first entry. Now I'll go to the first row, but multiply it by the second column. So first row, second column. 2 times negative 4 is negative 8. Negative 3 times negative 2, 6. I'm now done multiplying the first matrix. Let me erase that line for you. So I'm done with the first line of the matrix, so I now go to the second line. I'm going to multiply the second line, second row, with the first column. 1 times 1 plus, slide over, slide down, 5 times 3, 15. And now I'm going to move to the last column. So it's the last row, last column. 1 times negative 4 plus 5 times negative 2. And now we put all of this together. 2 plus negative 9, negative 8 plus 6, 1 plus 15, and negative 4 plus negative 10. There's your matrix multiplication for the 2 by 2. Okay, let's try another one. B times A. Now if you notice, AB and BA, these are the exact same matrices. I'm just changing the order that I'm going to multiply them in. First row times the first column. 1 times 2 plus negative 4 times 1, negative 4. First row with the second column. 1, negative 4, multiplying by here, negative 3, 5. 1 times negative 3 plus, slide over, slide down, negative 4 times 5, negative 20. We're done with the first row. We're going to move to the second row, first column. 3 times 2 plus, slide over, slide down, negative 2 times 1. And then second row, second column. 3 times negative 3 plus negative 2 times 5, negative 10. And now we can add everything together. Negative 2, negative 23, 4, negative 19. Now what I want you to notice is that we did not get the same answer. So even though the matrix numbers were the same, I changed the order in which I multiplied them. Matrix A times B will never give you the same answer as matrix B times A. Matrix multiplication is not commutative. You will not get the same thing. Are not commutative. Okay, let's try this one. A times B. A matrix is here. B matrix is here. We need to know the sizes to make sure this is going to work. This is a 3 row by 2 column, 3 by 2 matrix. The B matrix is 2 rows, 2 columns. The amount of columns of the first matches the number of rows in the second. So yes, this is definable. My answer matrix when I'm done should be of size 3 by 2. First row, first column. Negative 1 times 3 plus, slide over, slide down, 2 times negative 2, negative 4. Stay on the first row, but this time it'll be first row times the second column. Negative 1 times 2, 2 times negative 1. We are now done with the first row. Second row, first column. Negative 3 times 3. Slide over, slide down, 0 times negative 2. Second row, second column. Negative 3 times 2 plus, slide over, slide down, 0 times negative 1. We are now done with the second row. We go to the third row, first column. 4 times 3 plus 1 times negative 2. Done with the first column. Third row, second column. 4 times 2 plus 1 times negative 1. And now we just put the whole thing together. Negative 7, negative 4, negative 9, negative 6, 10, 7. And there is your 3 by 2 matrix multiplication answer matrix. When you do word problems with matrices, you want to be able to set up your matrix according to the words that are in the problem. If you can make one matrix that deals just with inventory, make that matrix. If you can make one matrix that just deals with cost, you want to try to do that. The answer matrix, when you multiply these together, would be what's called a total cost matrix. You always want to label everything. When you do your matrix multiplication, if you see things labeled, you'll know exactly what you're putting together. So the example that I want to talk through is example number 4 on page 198 in your book. 2 hockey teams submit equipment lists for the season as shown. Each stick costs $60, puck costs $2, each uniform costs $35. Use matrix multiplication to find the total cost of equipment for each team. So if you look on that page, they give you a big list there. So again, what we want to do is make an inventory matrix first, and then we want to make a cost matrix. So labeling 2 matrices, your inventory matrix will be the A matrix, your cost matrix is the B matrix. In your inventory matrix, if you look in the book, you've got 2 different teams. You've got a women's team and a men's team. Women will take row A, men will take row B, or the first row, second row, and your columns will be labeled stick, puck, uniform. Everything that they talk about in the particular question, and do it in the order that they give them to you. They talk about everything in order. Women's team is going to need 14 sticks, so I'm going to go to the row for women. 14 sticks, 30 pucks, and 18 uniforms. The men's team is going to use 16 sticks, 25 pucks, and 20 uniforms. There's my inventory matrix. Now I go to the cost matrix. In the particular word problem, it said that each stick cost $60. So I'm going to make my cost matrix going up and down, and again label them. Do them in the same order that you did the inventory matrix. Sticks comes first, then pucks, then uniforms. The cost for each stick is $60. The cost for each puck is $2, and the cost for each uniform is $35. So now I want to do my matrix multiplication. If we can look at the size of these matrices, we'll see what size they are and that it is a definable multiplication. This inventory matrix is 2 rows, 3 columns, 2 by 3. The cost matrix is 3 rows, 1 column. The amount of columns from the first matches the rows from the second, so this is definable. My answer matrix should be a 2 by 1 matrix. So now we have to think about the actual multiplying. The entire first row will multiply by the entire first column. So here's where you want to have your calculator handy. We're just going to do this by hand. Tomorrow I'll show you how to do this on your calculator. When you're multiplying, 14 times 60, first position is stick. First position over here is also stick. So you're multiplying how many sticks you need and the cost for each stick. 14 times 60. Plus, slide over, slide down. We need 30 pucks, and each puck costs $2. 30 times 2. Plus, slide over, slide down. We need 18 uniforms, and each uniform costs $35. That's for the women's team. Now I'm going to do this again for the men's team. I'm looking at my second row, and again with the column. I need 16 sticks. Each stick costs $60. 16 times 60. Plus, slide over, slide down. I believe this number was 25 right here before I erased. 25 times 2. Plus, and then slide over, slide down. 20 times 35. You can plug that into your calculator. You'll get 2 answers, one for the top line, one for the bottom line. The top line numbers, when you add all of these together, right here, 1,530. The second line added together, 1,710. The top line represents the cost for the women's team for all of their inventory. The second line is the cost for the men for their entire inventory. Like I said, tomorrow I'll show you on your calculator how you can edit your matrices and let the calculator do the work for you. But this is how this setup would look in terms of basic matrix multiplication. It's all about slide over, slide down, lining everything up, making sure that it is a definable matrix to start with, the amount of columns in the first matching the rows from the second, and then you can carry out your multiplication. All right, so that is it for 3.6 matrix multiplication.